Okay, we're going to start off with this practice problem. Give it your best effort, or at least pretend to. Nisha, you're in charge. All right. So, everybody, a lot of you asked me what ammonia was. That is a chemical you should have memorized.
I did NH4, so NH3.
That would be ammonium. We talked about that, but you were still out at lunch. All right, why'd I put a 2 there? Containing 2 ATM of all 3 gases. It's heated and allowed to come to equilibrium. At equilibrium, there are 1.7 ATM of hydrogen. Nitrogen, sorry. I don't know where the word hydrogen came from. That actually makes it a lot easier. Way easier. Okay, so the change here is a negative what? 0.3. To find the change, you take the end minus the initial, or the equilibrium minus the initial. You would get a negative number if you did it that way, but just find the difference. And if you remember, they're negatives for reactants, positive for products. You'll be good. Okay, that means this change is a negative what? 0.9, because the change is 3 times greater than it is for nitrogen. And the change here is 0.6. So we had 1.7, we now have 1.1. That was like a serious Goddard sneeze right there. 1.4. What did I do? Oh, 2. You're right. Add. Thank you. 2.6. Okay. You add this one. I just subtracted because I had just subtracted those other 2 and I was dumb. Okay. Next, the Kp would be equal to NH3 squared, correct? Over N2 to the first, we arrive at that, times H2 cubed. So I have 2.6 squared over 1.7 times 1.1 cubed. What do I end up with? 2.98? Oh, that's my high school GPA I graduated with. Yeah. Oh, no, it's not. No, it's not. No, it's not. It was a 2.89. My fault. I don't want to brag. I don't want to brag. I was like top 400 in my class.
Are you serious?
Yeah, bro. No, there was 900 kids in my grade.
That's like half right there. You're in the top half. Well, isn't a 3
Yeah. What's wrong with a slightly under a B average? You can turn out like this.
I'm actually one of those.
Okay, no more getting mad at us for our bad test scores, though.
That's not true. I was smart enough not to sign up for an AP class.
That is true.
Yeah.
That is true.
All right. So, yes,
Isn't that the PC that was that?
it might have been. It was ATM though, wasn't it?
Yeah, so it was all ATM, but it's just ATM.
If it's ATM, it's a pressure, so it's KP.
David said we're going to need for
A good attitude. All right. How many of you got 2.98 or something like it? Okay. How many have a 2.98 GPA? Oh, wait, I didn't. I forget. 2.89. How many have a 4.0? It's Bert. He's not even hard. Okay, here you go. Practice. Practice.
Yeah, if I fail, the
Practice.
final, it doesn't even affect me, but if Cooper fails the final.
You should always answer this one off of KC. Now, this one, they're the same, but if you have a KC that's larger than KP that's small, which happens, and it's super annoying, go after the K or use the KC to answer that question. All right, and you would say because the equilibrium expression is greater than 1, which means there are more products than reactants. Okay, this one we have to do this, and I can't remember. I will do it. I just don't want to do it in front of you and look stupid, which I already do. All right, everyone, this is a really good question from another chapter. If neon gas is added to the system at equilibrium, what would happen to the amount of N2 present? Nothing. Remember? No. 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 The pressure of a gas is independent of the pressure of any other gas. Remember that? Forever, the partial pressures from chapter 10. If we add a non-reactive gas, which, so you were right on that part, and to the equilibrium, it won't affect the pressure of the other parts. There will be, when we get to equilibrium, there'll be some of everything. Oh, then it should be BR.
Oh,
Sorry,
that would make more sense.
sorry. BR2.
I wasn't even focusing on that.
Neither was I. All right, let's talk. And I'll have to remember how to do this. Like I know how to do it, but I know I will screw it up if I do it in front of you. So I'll wait till later. Okay. Here we have a new concept, but it's the same, just a different letter. We have Q. What do you need? What do you need? Judah. All right, way to rep the sophomore class. Okay, I'm going to talk. Hopefully you listen. Q is the same as K. Make sure you listen. Q is the same as K. Tell your partner, Q is the same as what? K. So listen, why do we need 2 letters? Well, here's the deal. No, K is when we know it's at equilibrium. K is the equilibrium expression. Q is what we call the reaction quotient. It's the same exact math, but Q isn't guaranteeing we're at equilibrium. It's just saying, hey, we are at this specific set of conditions. What is this value? And then we compare Q and K to see which direction it's going to go. It's actually pretty slick, but the math is 100% the same. So it's nothing real new, but it's something really important. So to calculate Q, substitute the initial concentration of reactants and products into the equilibrium expression. Like the problem will give it to you. And then you'll plug it in and you'll get a value. And then the problem would tell you what K was, and you would compare them. Q gives the same ratio, which means the math is the same. The equilibrium expression gives, but for a system that is not at equilibrium. Now, that's not always true. Sometimes it gives you it and it is at equilibrium. And that's if you get Q and K and it's the same value, then it's at equilibrium. So here we go. If K equals Q, like these things right here are very important. If your K and Q are equal, the system, yeah, I want candy. Have you seen my body?
What?
Said, have you seen what I look like?
What kind?
Just,
Like Laffy Taffy or no,
just throw me something. Unless it's a banana Laffy Taffy, then we're not friends anymore. Good enough. Thank you. You nailed it. Okay. So if K equals Q, the system's where? All right, good. If K is, this will look confusing, but it really helps. Just trust me. Yeah, will you focus on, I just moved it. If K is less than Q, there's too much product and the equilibrium shifts to the left. Okay, now, if you do this, if you write this in alphabetical order, K always comes before Q, right? Then the greater than, whoops, or less than sign will point in the direction the reaction is going to go. Yes way. As long as you write K before Q, your greater than, less than will always tell you which direction it's going to go. It's going to go left, which means it's going to make more reactants. You with me? So if you do the math and K is, no, reactants are on the left. We're right here, make more reactants. So if K is a smaller value than Q, it will always make more reactants from where it's at. That means the amount of products goes down and the reactants goes up. That will make it reach equilibrium. All right. If you put it in alphabetical order and the greater than, less than sign will form an arrow and tell you what direction it goes. So if K is greater than Q, there is too much reactants and the equilibrium will shift towards the right or make more products. Always put K before Q and then just use the greater than, less than sign and it will tell you which way it's going to go. It's really slick. No. K and Q. No. Keep studying your map. It's okay. It's okay. He should be. That makes you study hard. Okay, so this is hideous, but whatever. If K is greater than Q, you make more products. If it's less than Q, make more reactants. If it equals Q, you're at equilibrium. This is really important concept, which means it's on your test. I could test you tomorrow if you want just a chapter 15 test. Anyone want one?
No.
Oh, weirdo. Okay, okay.
But I do want to
I'm very confused why you guys would ask for it.
Well, you're gonna get you can either get a chapter 15 tomorrow, or next try you get a 15 and 16 combined.
Wait, are you? Bring it on there.
Bring it on. You don't even have a 4.0 anymore.
Just kidding, I should don't bring it on. But we also, it's because of A plus too though. Oh, by the way, I'm gonna kill an A plus
What?
too.
You're gonna be freaked out.
I'm probably not going to.
I literally didn't realize.
I'm sorry. I
I
got your hopes up. I apologize. Okay. Shh. That's not in your body, Cooper.
Yeah, the Guadalupe.
No.
What are you talking about?
That was between me and Cooper. Everyone else,
You
chill.
heard what I was saying, right?
Chill, everybody. This is a degree.
Too many M's to ask someone to
That was good.
Oh my gosh.
Why would you do that?
Q equals.
the concentration of SO2 and the concentration of CO2 over the concentration of SO2 CO2.
All right. Then it gave me all that crap up here, right?
Yeah. So
0.035 times.
0.08.
Uh-oh, really?
Yeah.
Yep, you're right. That was dumb that I.
And then 5.
So
Yes, it is. No, it's 0.0056.
Oh, it's 0.0056? All right.
Is it 2 O's or 1?
1 sounds like. All right, so Q is 0.056. K is,
Yeah, I see 2 zeros.
okay, who has 2 zeros? Who has 1 0? Oh, okay. You wrong.
I also see 2 zeros. I can't read.
Oh, I see what one.
Dyslexia at its finest.
I'm sorry, guys.
And K is 0.078. Which one's greater?
Okay. So that means that there's products.
So I need my reaction to move where?
Towards you.
Yeah, Q, yeah.
Yeah, more products towards products, same thing.
So as Q gets closer to equilibrium, you'll get more product.
So which direction will it proceed? It will proceed towards the products, or you can say it makes more products or reactants go down. All three of those are the same kind of idea.
How can you test how many moles, like how many moles there are?
By its mass, how much mass it is, and knowing its molar mass. Okay, are we all right with that? Like K is a big deal, but it's not that big of a change. Do the math like normal. Put these in alphabetical order. Put your greater than, less than sign, and it will always point in the direction the equilibrium shifts. Always, always.
Wait, what do you mean from the direction equilibrium? I
Uh,
don't understand that. I can think it out in my head, get the right answer, but.
All right, in this whole chapter, we've been
Oh,
talking.
reaction from product. Oh, I see. That's what you've been saying.
Okay, we feel all right about that? So it's okay. So this arrow we make with our greater than, less than sign is really representing the direction that arrow is pointing. So since it pointed that way, we say it points towards products.
But Q has to be okay.
No.
No, it's alphabetical.
Put it alphabetical.
So does K?
And it doesn't have to. This is just a good way to not screw it up.
So K normally, if you put it in alphabetical order, it represents the reactant.
No.
What? Wait. Won't it be you're going towards?
Well,
the
I get what you're
reactant?
saying. I get what you're saying, but K is not a reactant and Q is not a product.
Well, yeah, but
We're
it's
just using the
represents-
comparison of greater than or less than to figure out which way it's going. So there's not a direct comparison to how you were saying that. All right, Le Chatelier's Principal. You're welcome. I know, it was a joke. Okay, Le Chatelier, have we talked about that in this class yet? All right, this is not hard. My regular kids just averaged 91% on this test. So here we go. Le Chatelier's principle says if a system at equilibrium is disturbed by a change in temperature, pressure, or concentration of one of the components, the system will shift its equilibrium position to counteract the effect of the disturbance. Oh, that's a lot of words.
It's sad that I perked up when you said that.
Reading hard for me is. All right. I have a little thing to demonstrate this. It's in the back room though. Cooper's not very mature. That's definitely not accurate. What am I doing? Okay, so pretend this is a reaction that's happening. The reactants are trying to produce products. They will produce products until the rate slows. And eventually they will reach an equilibrium. All right, so they will reach equilibrium. This block is here to make sure we remember equilibrium is not when the amounts are equal. It's when the amounts are not changing. Easy enough? So we are at equilibrium now. It is possible water's going this way and water's going that way. But since the height's not changing, we know we must be at equilibrium, right? Must be the same. Le Chatelier's principle says, if a system is at equilibrium and I add a stress is defined as a change in concentration or the amount of a substance. So I'm going to stress it by adding more reactants to the equation. Now, nothing's happening because I have my hand over here. My stress was to add reactants. What will the equilibrium do to fix it, or the reaction? It'll go over here. It will counteract or oppose what I do. So if I add to this side, where does the water move? Away from this side. So as soon as I let the reaction happen, it will move to counteract my addition and reestablish a new equilibrium. Now that's all Le Chatelier's principle says. If I come along, it's at equilibrium, I'm like, oh, I'm going to add more products to the system. Well, Le Chatelier's principle says that the reaction will oppose that action by going the other direction. As soon as I move my hand off, water will flow that direction, right? All right. So whatever side I add to, the reaction always goes away from that side. That's where, well, I erased it. That's where the little saying up there said add away. Whoops, not that. This. So if you will memorize this saying, you can get almost everything right. When you add, you always move away from where you added. If you take away, you always move towards the side you took away from. So this is harder, but I'll do my best. All right, so I've removed products. The system will oppose that action by producing more products. So the side I took away from, where does the water flow? Towards the same side I removed from. If I add, oh, my mask, I held it. If I add, I move away. If I take away, I stay. That's Le Chatelier's principle. It works for temperature, or sorry, heat, concentration, and pressure. And we will apply this as we go along. I don't remember what this video is. I'm intrigued. Oh, iBoss has blocked it. iBoss doesn't block YouTube anymore, but it does clean video search. We'll never know. Okay, bell's about to ring. I am teaching tomorrow. I probably won't teach Friday if you want that day off.
Wait, you're saying if I'm not here Friday?
We'll probably rest.